7th graders, this is Mrs. Tremblay with lesson 6.3 on surface area of cylinders. If you're following along in your book, you're going to want to open up your book to pages 264 and 265. Make sure you have your note sheet that you were given in class today. You definitely need to have a calculator, something to write with, always a good thing. Alright, we're going to start off with a little review, and we have talked about this in class quite a bit, and it's going to apply to what we're doing now. The area of a circle, we talked about this, it's pi times the radius squared. That's how you figure out the area of every single circle. The circumference of the circle is the distance around the circle. So area is what's on the inside. It's very sappy and thoughtful. Circumference is very superficial. It only cares about what's on the outside. So circumference, again, that's how long it takes to get around. So you calculate circumference by taking 2 times pi times whatever the radius is. Okay, this is why these formulas are important to us. They're part of a much larger formula right here. Don't get discouraged. It's not too bad. We'll explain what everything means. So, surface area of a cylinder. That's different than just the surface area of a circle. The area of a circle. Area of a circle is just 2 dimensions. When you're finding the surface area of a cylinder, it's like a whole bunch of little circles stacked up on top of each other. That's how I kind of see it. So the surface area, S, of a cylinder is the sum of the areas of the bases and the lateral faces. What on earth does that mean? The bases just mean the top and the bottom, and the lateral faces is just what's left, the side going around it. So again, bases, top and bottom, the lateral faces, it's around it. And you saw in class today that the bases are circles, and the lateral face is actually just one big rectangle. So in order to figure out the surface area of this whole thing, you're going to take pi r squared to find the area of the circle. But you have 2 of them, right? So you take 2 times pi times the radius squared. So basically you're doing the formula for the area of a circle and multiplying it by 2 because there are 2 circles in every cylinder. To that, you want to figure out the area of this rectangle and add it to it. So in order to do that, we learned that the circumference of this circle is equal to 2 times pi times the radius. And what I'm hoping you gathered in class today, I have a net set up just for you. Let's see if I can zoom out just a little bit. Okay, this is the net of a cylinder. And if we fold this up, it's kind of hard to see, but we'll have this cute little cylinder. And if you notice, this edge wraps all the way around, and circumference is the distance around that circle. So if it's your job to figure out what the area of this rectangle is, you have to know this side length and this side length. So right here, this side length is equal to 2 pi r. And we also need to multiply that by the height of the cylinder. So 2 pi r h is not just some magic formula somebody made up. The 2 pi r is the same thing as the length of the rectangle, and the h is kind of like width if you're thinking about length times width. So that's where this all comes from, and this kind of explains the whole thing. Let's try some. Let's get to the nitty-gritty, the fun part, I think. Here we have a lovely little cylinder. We're supposed to find the surface area, and I ask you to round to the nearest tenths place. All right. So we know that our formula is the surface area is equal to 2 pi r squared plus 2 pi r h. We just have to locate those things in our cylinder. So I know 2, it's already set for me. And we told you to always use 3.14 for pi. And when I look at this cylinder, I see that here's the circle. Radius is halfway across. So the radius, I would plug in a 4 for the radius. And I'm supposed to square it. Plus 2 times pi is 3.14. I'm going to have to jump down to the bottom here. Times the radius again, which is 4, multiplied by the height. So we can see this is not half of the circle. This is half of the circle. That's the radius. This is how tall it is. That's the height. So at this point, you can grab your calculator, type it all in. 2 times 3.14 times 4, and you saw that cute little x squared button on your graphing calculator. If you don't have one of those graphing calculators, then 4 squared just means 4 times 4, plus 2 times 3.14 times 4 times 3. When you do all that, you should get, I'm hoping you got, 175.84 millimeters squared. Now, I told you to round to the nearest tenths place, and if you're following directions, we would say 175.8, because the number next to the 8 is 4 or less. That means it stays the same. Millimeters squared. All right, next example. This one fell over. Just to confuse you. The poor cylinder, is it going to make it? We must find the area to save its life. I don't know, it's math. It's tough to make it exciting, isn't it? I try. Find the surface area, round to the nearest tenths place again. Okay, so we have our crazy formula. It equals 2 times pi times the radius squared plus 2 pi RH. All right, let's plug it all in. S equals 2 times, for pi we are using 3.14, times, now when you look at this is the circle. Okay, so this 4 has nothing to do with the radius. The radius is halfway across the circle. I drew a full line here and it says 6. That's the diameter. So in order to figure out the radius, remember the radius is equal to the diameter divided by 2. So I'm going to use 3 for r. So that's 3 squared plus 2 times 3.14. Again, I'm supposed to use the radius. The radius is not 6, it is 3. And I want to multiply that by the height. Now I know it fell over on its side, but when I'm sleeping, I'm still the same height. This is the height. It's 4. So I'm going to multiply that by 4. All right. Plug it all in. Do it. Do it right now. 2 times 3.14 times 3, and if you have the fancy little x squared, press that. If not, type in multiply by another 3, plus 2 times 3.14 times 3 times 4. And when you do all that, you end up getting 131.88 inches squared. But I said tenths place, so please follow the directions. And this time the number next to the 8 is 5 or more. That means I have to bump it up. So 131.9 inches squared. All right, we always got to throw a curveball at you. I'm asking you something different in this one. How much paper is used for the labels on the can? We have some yummy, mushy peas. So hopefully you get to go eat some mushy peas after this and you finished your notes before dinner. Otherwise, you're probably really, really hungry looking forward. Okay, rounding to the nearest tenths place. Now, I just asked how much paper is used for the label on the can, and if you've seen a can before, the top does not have a label on it, and neither does the bottom. Just this part right here, right? So if we go back to our formula, the surface area for the whole shebang is 2 pi r squared plus 2 pi RH. This right here, this 2 pi r squared part, is for the area of the circles. We don't need the area of the circles, we only need the area of the rectangle, which is represented by this part. So in order to figure out how much paper we need, we just need to take 2 times pi times the radius times the height. We don't need to do the other portion because we don't need the circles. We're not putting a label on it. So the surface area would be 2 times 3.14 times, when I look at this, I see they actually gave me the radius. It's 1 inch, so times 1. And the height of this can is 2. So 2 times 3.14 times 1 times 2. You would need 12.56 inches squared, and I did say tenths place. So number next to the 5 is 5 or more. That means it's going to be 12.6 inches squared. See you tomorrow.
Yay, Mrs. Trombley made it in under 10 minutes. Woo woo!